So that we can understand some properties of our molecules later on, we need to know something about the shapes of those molecules. So let's take a look at molecular shape. Let's jump right in. So looking at the shapes of an atom, the shape is determined by how many groups or atoms or electron pairs are on that atom. So for instance, if I have two things on an atom, maybe two different atoms, because if it's two things, it's sp hybridized, one s and one p orbital mixed together to make two hybrid orbitals. These electrons in this bond and these negative electrons in this bond, since they're the same charge, they try to get as far away from each other as they can. They'll get 180 degrees away from each other. And we call the shape of that molecule then, or this atom, linear, because it's in a straight line. Now if I have three things on that atom, maybe three different atoms, I need to have the hybridization of one s orbital and two p orbitals, 1, 2, 3 of them mixing together to make three sp2 hybrid orbitals on this atom. So it's sp2 hybridized. And I have three different groups on it. The name of this shape for this atom, it looks like a triangle that's all in the same plane, the plane of the paper. So because it's a triangle, we call it trigonal. And because all of those atoms are in the same plane, the plane of the paper, we call it trigonal planar. Now if an atom has four different atoms on it, we've seen earlier that means it's sp3 hybridized. Four orbitals mixing together, one s and three p's, to make four sp3 hybrid orbitals. And that sp3 hybridization causes four different groups on it. And when these negative electron bonds get as far away from each other as they can, they end up 109.5 degrees away from each other. We call this shape tetrahedral. Now the drawing of a tetrahedral shape, we have a line and a line. The regular lines mean those atoms are in the plane of the paper. If I have a wedge like this, that means this bond, it's coming towards us, outside of the paper towards us. If you have a dashed line, that means this atom and its bond is going behind the paper, away from us. So towards us, away from us, in the plane and in the plane. This is a tetrahedral shape. These are the three basic shapes of our molecules. So let me give an example of each of these. This might be something like carbon dioxide, would be linear, two oxygens on a carbon. Maybe a triple bond on my carbon, 180 degrees away from each other. This carbon would be linear. Trigonal planar might be something in organic chemistry like a carbon with an oxygen on it, maybe a hydrogen, maybe a hydrogen. So 180 or 120 degrees away from each other, three things on this carbon, it would be a trigonal planar carbon. And something with four on it, maybe a carbon with four different groups. Maybe they're all hydrogens, like methane, a tetrahedral kind of shape. Now sometimes all three of these things or all four of these things might not be, they might not all be atoms, like a hard atom. Instead, it might be an invisible, fluffy electron pair of electrons. So an invisible pair of electrons. So let's give you an example of that. Let's take, so let's just draw it with spheres like this first. So what if one of those spheres, instead of being a sphere, was an invisible pair of electrons? So it's invisible. You can't see those. Well, I don't want to call it a triangle plane, a trigonal planar anymore. Instead, now my shape of the central atom, it's more bent. So we call that bent. Some people call it angular. An example with that, of this might be something like SO2 or something. And some atom with a lone pair of electrons and some other atoms attached. Not very common in organic chemistry, probably. Now, for a tetrahedral like this, maybe if instead of all four of these being hard atoms, what if three of them were? Oh, so the one coming towards us, the one going away from us, and then one over here. And we'll make the top one just a lone pair of electrons, something invisible. So that shape looks more like there's a triangle on the bottom of it, and it looks like a pyramid. So this is a trigonal, because the base is a triangle, pyramid. It has a trigonal pyramidal shape. And this might be something like, sometimes wedges are drawn open like this. I'll do that just so you can see another example. Ammonia has this 109.5 degree shape, more or less. And these three hydrogens point down, and it looks like this, like a triangle pyramid. But what if two of those are electrons? So in this case, let me draw two atoms on it, two hard atoms. And maybe one invisible lone pair of electrons is coming towards us, and maybe an invisible pair of electrons is going away from us. Because there's four things, two atoms and two lone pairs, it'll be sp3 hybridized. It'll get into this tetrahedral kind of shape, but we no longer call it a tetrahedral shape because these are invisible. I only see these three atoms. So it looks like a bent molecule. So we call this one bent. But all of these are in the same grouping. They all have four things, four atoms or four lone pairs of electrons. The central atom is always sp3 hybridized if there are four things on it. And we call them tetrahedral. If they're all there, all of them are atoms. If it's a little pyramid instead, it would be a trigonal pyramid, or it could be bent. All of these were the same too. These were the same. We call it trigonal planar if all three of those things are there, like an atom. And we call it bent if one of those is an invisible pair of electrons. So that's the basic overview of our simple shapes of atoms in our organic molecules. So I hope that was helpful. Simple overview. Hey, subscribe to the channel so you can watch more of these videos, and I can help you on your organic chemistry journey.